Hello everyone, good evening. So here we shall solve some more JEE Mains previous year questions on the chapter units and measurements. So any doubts if you have in any steps, then please write that in the comments section. We shall obviously clarify them in the subsequent videos. Also in any other chapter of physics, if you have more difficulty, then please write the name of that chapter in the comment section so that we can give more priority on it and solve more and more questions on that chapter. Also, some important homework questions on every chapter will be uploaded in the Sapience Education application. So please install our Sapience Education application, whose link has been provided in the description. Then here it is told two bodies are projected from ground with same speeds 40 meter per second at two different angles with respect to horizontal. The bodies were found to have same range if one of the body was projected at an angle of 60 degree with horizontal, then sum of the maximum heights attained by the two projectiles is m, given g equal to 10 meter per second squared. So this m we have to find. So same horizontal range is happening, it means, and initial speed is same, it means u square sine 2 theta by g, as you know, is the range. So if we take theta 2, which is the angle of projection of the second body, angle of projection of the second body, that will be equal to 90 degree minus the angle of projection of the first body. Then sine 2 theta 2, that will be equal to sine 2 into 90 minus theta 1, that will be equal to sine 2 theta 1. So it means that their ranges will be the same. So therefore, if one of the angle theta 1 is 60 degree, then the angle of projection for the second body, that will be 30 degree. And therefore, the maximum height attained by the first projectile, that is, let's say that is h1. So h1 will be equal to u square sine square theta by 2g. And h2 will be equal to sine square u square sine square theta 1 by 2g, and this is u square sine square theta 2 by 2g. Therefore, h1 will be 40 square into sine square 60 degree divided by 2g. G is 10. So this will be 40 square, that is 1600 into sine square 60, that is 3 by 4 into 1 by 20. So this will be 4 4 is 16, so 220, that is equal to 60 meter. And maximum height for second body, that is u square sine square 30 degree divided by 2g. So this will be 1600 into 1 by 4 into 1 by 20. So 400. So 220, that is equal to 20 meter. So therefore m, which is the sum of the maximum heights attained by the two projectiles. So m will be equal to h1 plus h2, that is 60 plus 20 meter, that is equal to 80 meter. So it means 80 meter is the sum of the maximum heights attained by the two projectiles. Here it is told the speed of a swimmer is 4 km per hour in still water. Speed of a swimmer Vs, that is 4 km per hour in still water. So it is speed of swimmer with respect to water. If the swimmer makes his strokes normal to the flow of river, so he applies his strokes perpendicular to the river flow, He reaches a point 750 meter down the stream on the opposite bank. So this length is 750 meter. So this way we'll see, suppose the speed of the stream, speed of the uh, river, and this way is the speed of the swimmer. So this way will be the resultant speed. So the width of the river, that is 1 kilometer. 750 meter means 0.75 kilometer. So the time taken by him to reach the opposite bank, that will be equal to the width of the river divided by the speed of the swimmer, since he applies his strokes normal to the flow of the river. Is 1 kilometer divided by 4 kilometer per hour. So this is 1 by 4 hours. 1 by 4 hour he takes. So therefore, the speed of the river water has been asked, VR. So therefore, VR into T, that will be equal to 0.75 kilometer. So speed of the river, that is 0.75 kilometer divided by 1 by 4 hour, that is 0.25. So 0.75 kilometer by 0.25 hour. So point will cancel. 25 3 is 75. So that is 3 kilometer per hour. So 3 kilometer per hour is the speed of the river water. So 3 kilometer per hour is the answer. And here it is told a horse rider covers half the distance with 5 meter per second speed. A horse rider is there. Okay. A horse rider, it covers half the distance. Let's say it covers the distance x with a speed v1, that is 5 meter per second. The remaining part of the distance, that is x, that was traveled with speed 10 meter per second for half the time, and with 15 meter per second for the other half of the time. So here let's say he took time t, and here the speed v2 was 10 meter per second, and here also the time taken was t. This was and in the third case the speed was 15 meter per second. The mean speed of the rider averaged over the whole time of motion is x by 7 meter per second. The value of x is. So the average speed, which is averaged over the whole time of motion, that is x by 7 meter per second. Then we have to find out x. Now, the average speed, that will be equal to the total distance covered divided by total time. The total distance covered divided by total time taken. So the total distance, that will be equal to so here this x I can tell that is v2 into t plus v3 into t. It means that is 10t plus 15t. So this is equal to 2x by x by v1 plus 2t. Yeah, x by v1 plus 2t. X by v1 plus 2t. Okay. Now, so this will be 2x. So x is equal to 15t. So I can say 2 into 15t, or I can say, okay, this will be equal to 2x divided by x by v1 plus this will be 2t. So 25t, that is equal to x. So t will be equal to x by 25. So this is 2x by 25. So therefore the average speed that will be equal to 2 by this 1 by v1, so 1 by 5 plus 2 by 25. So this will be 2 by, the LCM is 25, 5 5 is 25, 5 plus 2, so that is equal to 50 by 7 meter per second. So therefore the value of x is equal to 50. 50 is the answer. Then it is told a tennis ball is dropped on the floor from a height of 9.8 meters. The height from which it is dropped, that is 9.8 meters. This is the floor. It rebounds to a height. It rebounds to a height of 5 meters. The ball comes in contact with the floor for 0.2 seconds. The ball comes in contact with 0.2 seconds. The average acceleration during contact is. So the average acceleration during contact, that will be the change in velocity by the time interval during contact. So the velocity with which it will hit the ground, let's say that is v1. So v1 will be equal to, it is, the tennis ball is dropped on the floor. So it is dropped means its initial velocity is 0. So it is equal to u plus gt, where g is equal to 10 meter per second square. So v1 will be equal to gt, g, that is, okay, time has not been told, so bounds, okay. So I can tell v square equal to u1 square equal to u1 square plus 2gh. That means v1 square, that will be equal to 2 into 9.8 into 10. 2 into 98. So v1 square, that is equal to 2 at the 16, 2 at the 18, 196. So therefore v1 is square root of 196, which is equal to 14 meter per second. So it hits the floor with a speed of 14 meter per second, and it then the velocity changes to, let's say, some speed v2. Then it rebounds to a height of 5 meters. It means that this v2 we can find, since the final velocity v, that is 0 when it reaches the highest point. So therefore again we can say that v square, that is equal to v2 square u square minus 2gh minus 2 into 5 2g, g is 10, okay, 2g into h, that is 5. So this is 0 square, that is v2 square equal to 100. So v2 square minus 100. So v2 square is equal to 100. So v2 will be 10 meter per second. So it means that it rebounds with a speed 10 meter per second. So therefore now the average acceleration that is equal to, we can say v1 minus of minus v2. Since why? Let's say if we take the downward direction as positive, then upward direction will be negative. It means v2 is in the negative direction. So average acceleration means v final minus v initial by delta t. Now the time interval that is given as 0.2 seconds, since it is told the ball comes in contact with the floor for 0.2 seconds. And v final, that is obviously I can say that is v2 j cap, and v initial, that is equal to v1 minus j cap. It means suppose we take the upwards as positive y-axis and downwards as negative y-axis. Then v1 is minus j cap. So if we do v final minus v initial, then we will have v2 minus v2 minus of minus v1 by 0.2 seconds. So v2 plus v1 by 0.2 seconds. So that will be equal to v2 is 10 plus 14 by 0.2, this much meter per second square. So this will be 24 by 2 into 10. This will be 120 meter per second square. 10 plus 14, yeah. So so this will be the average acceleration during contact is 120 meter per second square. So this is the answer. Then here it is told a, a juggler throws balls vertically upwards with same initial velocity in the air. So when the first ball reaches the highest position, where v equal to 0, he throws the next ball. Assuming the juggler throws n balls per second, maximum height the balls can reach is. So it means that n balls per second, n balls he throws per second. It means that the time of flight for each ball, the time of flight for one ball or for each ball, that is equal to 1 by n seconds. 1 by n seconds. 1 by n seconds. So in 1 by n seconds, it will reach the highest point. So therefore, the maximum height the balls can reach is, so to find the maximum height the ball can reach. So as you know, s equal to ut plus half at square, or I can say v square equal to u square, v square equal to u square plus 2s. So here the final velocity is 0 and u is, let's say the initial velocity is u and g is acting vertically downward. So acceleration will be equal to minus g. So this will be equal to minus 2gh. And v, that is equal to u plus at also. U minus g into t. T is equal to 1 by n. From here we can see that u equal to g by n. V equal to g by n, then we have to find h. So therefore h equal to u square by 2g. H equal to u square by 2g. So this will be equal to u square, which is g by n. G by n actually, g by n, not h. That is g by n whole square into 1 by 2g. So this will be equal to g square by n square into 2g. So g and g will cancel. So this is g by 2n square. G by 2n square. So option D is the correct answer. Then here it is told a ball is released from a height h. A ball is released from a height h. Ball is released from a height h. If t1 and t2 be the time required to cover the first half and second half of the distance respectively, then choose the correct relation in between t1 and t2. So the first half it reaches in time t1 and the second half it reaches in time t2. Then the relation in between t1 and t2 is how much? So it is released from here. So initial velocity will be 0 here. And this is the ground. And this is the height h by 2. So therefore h by 2 is the displacement in t1 in the first t1 second. So h by 2 will be equal to ut. So u into t1 plus half gt1 square, since g is acting vertically downwards and we are considering the downwards as the positive direction. And so it means h by 2 that will be equal to half gt1 square since u is 0. So therefore t1 that will be equal to h by g. And t2 So here the final velocity that it will reach, let's say that is v1. So you can say v1 square, that will be equal to u square plus 2g into h by 2. So it means v1 square, that is equal to gh. So v1 equal to root gh. So here the velocity is root gh. Then from here the time required is t2. So therefore I can say that s, that is h by 2, equal to ut, that is v1 into t2, v1 into t2. Since here the initial velocity is v1, in the next half, of the distance covered, the time required is t2. So v1 into t2 ut plus half g t2 square. Then h by 2, that will be equal to v1 is root gh into t1 t2 plus half g t2 square. Or we can say the time it takes to reach the ground, that is t1 plus t2. So therefore I can say h, that is equal to u into t1 plus t2 ut plus half g into t square, is t1 plus t2 whole square. So u is 0, so I can say half g into t1 plus t2 whole square, that is equal to h. So therefore t1 plus t2 whole square, that is equal to root over 2h by g. So t1 plus t2 is root over 2h by g, and t1 which we have found, that is h by g. Sorry, t1 square is h by g. So t1 will be obviously root over h by g. So t1 is root over h by g. So now therefore t2 plus t1, that is equal to root 2 times root over h by g, means it is root 2 times of t1. So therefore t2 will be equal to root 2 minus 1 into t1. So t2 equals to root 2 minus 1 into t1. So option D is the correct answer. Then here it is told a ball is thrown up vertically with a certain velocity u so that it reaches a maximum height h. Then find the ratio of the times in which it is at height h by 3. So maximum height h, and the ratio of the times in which it is at height h by 3 while going up and coming down. Thrown up vertically with a certain velocity so that it reaches a maximum height h. Find the ratio of the times in which it is at height h by 3 while going up and coming down. So while going up, it will reach a height h by 3, let's say at time t1, and while uh, returning back also, it will reach a height h by 3 at time t2, suppose. So then we have to find the ratio of the times t1 and t2. t1 is to t2 means t1 by t2, the value of that we have to find. t1 by t2 has been asked. So now when it will reach h by 3, so we can say that so at the highest point velocity is 0, so we can say v square equals to u square minus 2gh. Since g is acting vertically downwards, so therefore u square equal to 2gh. So u equal to root 2 gh. Now when it will reach a height h by 3, so therefore we can say that s equal to ut plus half h square. Now s is equal to h by 3 and u into t plus half g, acceleration is minus g into t square. So this time we have to find out. So therefore we can say is half gt square minus ut plus h by 3, that is equal to 0. So therefore the time will be equal to, t will be equal to minus b plus or minus b square minus 4ac by 2a. 2a means g by 2. Okay. 2 will cancel. So 2 2s are 4. So this will come u plus or minus square root of u square minus 2gh by 3 by g. So therefore the time of the times t1 is to t2 that we have to find. So t1 will be the, if we take the minus sign, then we will get t1, since t1 is less than t2. Since while going up it should be at a lesser time, and while coming down it should be at a greater time. Since first it will go up and then after some time it will return back to that same height. So it means obviously t2 is more than t1, since t2 is the time when it will reach h by 3 while coming down, and t2 and t1 is the time when it will reach h by 3 while going up. So t1 is u minus root over u square minus 2gh by 3 by g. Now u is equal to root 2gh, so u minus, we can say 2gh, u square is 2gh minus 2gh by 3 by g. So this will be root 2gh minus 1 minus 1 by 3, that is 2 by 3. So it is root over 4gh by 3 by g. And t2, that is equal to u plus root over u square minus 2gh by 3 by g. So this will be u, which is root over 2gh plus root over 2gh into 1 minus 1 by 3, that is 2 by 3. So 4gh by 3 by g. And then t1 is to t2, we have to find out. Now t1 is to t2, so t1 by t2, so that will be equal to root over 2gh minus root over 4gh by 3 divided by g divided by root over 2gh plus root over 4gh by 3 over 4gh by 3 by g. So g and g will obviously get cancelled. And this will be equal to root 2 minus root 4, which is 2 by root 3 divided by root 2. Since by g root gh I can cancel out, plus this is 2 by root 3. Now we can multiply by root 3 and we can divide by root 2. So that will be equal to 1 minus root 2 by root 3 by 1 plus root 2 by root 3. So this will be root 3 minus root 2 by root 3 plus root 2. Root 3 minus root 2 by root 3 plus root 2. So option B is the correct answer. Then here it is told, if t equals to root x plus 4, then dx by dt at t equal to 4 is how much? So then root x I can tell that is t minus 4. So therefore x will be equal to t minus 4 whole square. So it means that, and here x should be greater than or equal to 0. X should be greater than or equal to 0. And root x also should be greater than or equal to 0. So t should be more than or equal to 4. t can't be less than 4. And so then dx by dt, that will come 2 into t minus 4 into 1, 2 into t minus 4. So therefore dx by dt at t equal to 4, that will be obviously 2 into 4 minus 4, that is equal to 0. So option B is the correct answer. Then here it is told at time t equal to 0, a particle starts traveling from a height 7 z cap centimeter in a plane keeping z coordinate constant. So z coordinate is constant, it means the plane is parallel to the xy plane. Let's say this is xy plane, this is the z axis. So z, so it is located at 7 z cap. This is the origin, so it is located at 7 z cap. It means it is located at 0, 0, 7, and it is moving in a plane keeping z coordinate constant. It means it is moving in a plane which is parallel to the xy plane. It is mo- m- moving at any instant, of time. Its position along the x cap and y cap directions are defined as 3t and 5t cube respectively. So it means that its x coordinate is 3t and y coordinate is 5t cube. So it means that at any instant it is located at 3t comma 5t square 5t cube comma 7. It means the position vector at any time t, that is equal to 3t I cap 3, or I can say 3t x cap plus 5t cube y cap plus 7 z cap. So at t equal to 1 second, acceleration of the particle will be equal to 1 second. So now acceleration. So first we have to find the velocity at any time t, that is equal to dr by dt. So that will be equal to 3x cap plus 3 5 is 15, 15t square y cap plus 0 z cap. And then acceleration at any time t, that will be equal to dv by dt. So that will be equal to 0 x cap plus 215 is 30, 30t y cap plus 0 j cap, z cap. So therefore the acceleration of the particle at any time t, that is equal to 30t y cap. So now therefore the acceleration at t equal to 1 second, acceleration at t equal to 1 second, that will be equal to 30 y cap, 30 y cap. So option B is the correct answer. So here it is told that NCC parrot is going at a uniform speed of 9 km per hour under a mango tree. There is a mango tree. So here the NCC parrot is going on. So on which a monkey is sitting at a height. A monkey is sitting at a height of 19.6 meters. At any particular instant, the monkey drops a mango. A cadet will receive the mango whose distance from the tree at the time of drop is. So at what? So the cadet should be placed at what distance from the mango tree? Let that be x. So this x we have to find out when the monkey will drop the mango. When the monkey will drop the mango. So the time that the mango will take to reach the ground. So in that time, the carrot also should reach under the mango tree. So here G is given as 9.8. So H we know that will be equal to half GT square since it is dropped. So its initial velocity of the mango is 0. So h will be equal to half gt square. So t will be equal to root over 2h by g. So t will be equal to root over 2 into 19.6 by 9.8. So which is equal to 9.8 into 2. So therefore t will be equal to 2 seconds. So the NCC parrot is going on with a uniform speed v. So v is 9 kilometer per hour, which is 9 into 5 by 18 meter per second. So that is 9 to the 18. So 5 by 2 meter per second. So therefore the distance of the cadet from the tree when the mango is released by the monkey, that x will be equal to v into t. So v will be 5 by 2 into 2 meter. So that is 5 meter. So it means the cadet should be at a distance of 5 meter from the m- m- mango tree at the time when the mango is dropped by the monkey. Option A is the correct answer. Then here it is told the velocity of the bullet becomes 1/3 after it penetrates a 4 centimeter uh, after it penetrates 4 centimeter in a wooden block. So after it penetrates 4 centimeter in a wooden block, then the speed of the velocity of the bullet becomes 1/3. So let's say its initial velocity is u, and here the final velocity will be u by 3. Assuming that bullet is facing a constant resistance during its motion, means the resistive force is constant. Resistive force is constant. It means the retarding force or the retardation, that A will be constant. Then the bullet stops completely after traveling at 4 plus x centimeter inside the block. So when it travels 4 plus x centimeter inside the block, then the bullet stops completely. So here the velocity, final velocity v1 will be 0. So then the value of x is how much? So therefore we can say that v square equal to u square plus 2as. So now therefore u by 3 whole square, that is equal to u square minus 2a into s. S is 4 centimeters, so it is 0.04 meters. So therefore I can say u square minus u square by 9, that is equal to 0.08a. Therefore the retardation, that will be equal to 8 u square by 9 into 1 by 0.08. So this will be equal to u square. So 8 0.1 8 1 8 is 1 by 100. So this is so therefore u square equals to 100 u square by 9. It means u is equal to 10 u. So a, this is a, sorry, a is equal to 100 u square by 9. So a is equal to 10 u by 3. So it means the retardation is 10 u by 3. Then at which distance the bullet will stop? At 4 plus x centimeter. So therefore I can say v1 square, that is equal to u square plus 2as. Sorry, this is minus 2as. So v will be, so v1 will be 0 if the displacement s is 4 plus x centimeter. So it means that is 4 plus x by 100 meter. Then x we have to find out. So 0 square equals to u square minus 2 into 10 u by 3 into s. S is 4 plus x by 100. Sorry, here a square. Sorry, a is 100 u square by, sorry, this is root a. So a is 100 u square by 9. A is 100 u square by 9. So 100 will cancel out. And here it means we will get u square equals to 2u square by 9 into 4 plus x. So u square will cancel. So then we get 9 equals to 8 plus 2x. So x equals to 1 by 2 meter, which is 0.5. Sorry, x is 0.5 centimeter. So x will be equal to 0.5. So option C is the correct answer. Then here it is told a bullet is shot vertically upwards with an initial velocity u equal to 100 meter per second from a certain height. From a certain height from the ground, from a certain height from the ground, the bullet is shot vertically upwards. Then it is told within 10 seconds, uh, okay, it is shot vertically downwards. Okay, so it is wrong. It is shot vertically downwards from a certain height. Let's say from this height, it is shot vertically downwards with some initial velocity u, which is 100 meter per second. Within 10 seconds, the bullet reaches the ground. It means t equal to 10 seconds, and instantaneously comes to rest due to the perfectly inelastic collision. So here, the bullet comes to rest. V equal to 0. The velocity time curve for the total time t equal to 20 second will be. So the initial velocity is vertically downward. So if we take the upwards as the positive y-axis, then downwards will be negative y-axis. So therefore, the initial velocity I can tell u equals to minus 100 meter per second, and then final velocity is 0. The acceleration is minus g, which is minus 10 meter per second square. So you can say v equals to u plus 80. So this will be v equals to minus 100 minus 10 into t. So therefore at t equals to 10 seconds, the velocity with which it hit the ground, that will be minus 100 minus 100 minus 10 into 10. So this is minus 200 meter per second. So therefore the graph of Vt, the graph of velocity versus time, that will be, so at t equal to 0, this is minus 100 and this will be minus 200. Minus 200. Then suddenly it will come to rest. So it means that option A is the correct answer. Then it is told two projectiles are thrown with same initial velocity, making an angle of 45 degree and 30 degree with the horizontal respectively. The ratio of their respective ranges will be the projectiles, two projectiles are thrown with the same initial velocity. Okay. The ratio of the respective ranges. Okay. So range, as we know, that is equal to u square sine 2 theta by g, where u is the initial velocity and theta is the angle with the horizontal at which the projectile is being thrown. So theta is also called the angle of projection, and u is the initial uh, velocity and r is the horizontal range. So now, therefore, if theta equals to 40 5 degree, then the range, that is R1, that you can say that is u square with sine 90 degree divided by g. So sine 90 is 1, so it will come u square by g. And similarly, if the angle theta equals to 30 degree with the horizontal, then the range will come as u square sine 2 theta. So it is 2 into 30, that is 60 by g. So that will be u square by g into root 3 by 2. Therefore, R1 is to R2. R1 is to R2, so it will be u square by g into root 3 u square by 2g. U square by g will cancel. So this is 2 is to root 3. So the ratio of the ranges will be 2 is to root 3. So option C is the correct answer. When it is told two projectiles are thrown at 30 degree and 45 degree with the horizontal respectively, reach the maximum height in same time, the ratio of their initial velocities is. So the time required to reach the maximum height, that is the half of the time of flight. So the time to reach the maximum height, let's call it as Tm. So that is actually half of the time of flight, which is equal to u sine theta by g. So this time of flight is the time to reach the maximum height is the same, but theta is the angle of projection with respect to the horizontal. So therefore we can say that the ratio of their initial velocities have been asked. So here it is told Tm1 that is equal to Tm2. Then u1 is to u2 is how much? U1 is to u2 you have to find out. So this implies that u1 sine theta 1 by g, that is equal to u2 sine theta 2 by g. So it means that u1 by u2, that is equal to sine theta 1 by sine theta 2 by sine theta 1. So that will be sine theta 2, that is sine 45 degree divided by sine 30 degree. Therefore, u1 by u2, that is equal to sine 45, that is 1 by root 2 by sine 30, that is 1 by 2. So it means that is equal to 2 by root 2, that is equal to root 2 by 1. Therefore, u1 is to u2, that is equal to root 2 is to 1. So it means the ratio of their initial velocities is root 2 is to 1. So option C is the correct answer. Then it is told that a ball is projected from the ground. A ball is projected from the ground with a speed of 15 meter per second at an angle theta with the horizontal, so that its range and maximum height are equal. So that its range and maximum height are equal. Range and maximum height is same, then tan theta will be equal to how much? So here it is told that maximum height that is equal to the range. So maximum height, that is u square sine square theta by 2g. that is equal to u square sine 2 theta by g. So g and g will cancel, u square will cancel. So then we will get sine square theta by 2, that is equal to 2 sine theta cos theta. So sine theta will cancel. So then we'll get tan theta, that is equal to 4. So then tan theta will be equal to 4. So option D is the correct answer. Then it is told at t equal to 0, truck starting from rest moves in the positive x direction at uniform acceleration of 5 meter per second square. At t equal to 0, starting from rest. At t equal to 0, starting from rest, moves in the positive x direction. So it is told that at t equal to 0, starting from rest, the truck starting from rest moves in the positive x direction with a uniform acceleration of 5 meter per second square at t equal to 0. It starts from rest, which is u equal to 0. Then at 20-second, a ball is released from the top of the truck. At t equal to 20-second, a ball is released from the top of the truck. The ball strikes the ground in 1 second after the release. The velocity of the ball when it strikes the ground will be. So it will have some horizontal velocity. So it will move in a parabolic path and it will reach the ground at t after t is equal to 1 second. Means at t equal to 21 second it will reach. Since it is released at t equal to 20 second, then the velocity of the ball when it strikes the ground will be okay. So it means the horizontal velocity with which, let's say v1, the horizontal velocity with which the ball will move, so that will be, so that will be same as the horizontal velocity of the truck at t equal to 20 second. So as you know, v1 equals to u plus at. So u is 0, so therefore v1 will be equal to 5 into 20, that is 100 meter per second. Then it will come downwards with how much speed, that we have to find out. It will come downwards with how much speed. Will come downwards with how much speed. So it means that the x component of the velocity will remain the same, that is 100 meter per second, that is vx, and vy that will be equal to uy plus gt, since g is acting vertically downwards. So vy is the y component of the final velocity of the ball when it strikes the ground. So then vy that will be equal to, and the final velocity of the ball that will be equal to vx I cap plus vy minus j cap. Since y it is the vy is vertically downwards, and since we should take vertically upwards as the direction of positive y-axis, so vy that will be equal to uy, that is 0 plus g into t. G is 10. G we have to take 10, it has been told. 10 into t. T is 1 second. So this will be 10 meter per second. So therefore, the velocity of the ball when it strikes the ground, that will be, that is v1 only. This is 100 I cap minus 10 j cap. 100 I cap minus 10 j cap. So this will be the velocity of the ball with respect to the ground. So option A is the correct answer. Then here it is told two projectiles P1 and P2 thrown with speed in the ratio √3 is to √2 attain the same height during their motion. If P2 is thrown at an angle of 60 degree with the horizontal, the angle of projection of P1 with horizontal will be. So here it is told the projectile P1 is thrown with an initial velocity u1, that is, let's say √3u, and they attain the same height h, and the angle of projection θ1, that is 60, no, that we have to find out. And P2 is the second projectile where the initial velocity u2, I can say that is √2u. Since here it is told that u1 is to u2, that should be √3 is to √2. They are thrown with the speed in the ratio √3 is to √2. And θ2, it is 60 degrees, since it is told that if P2 is thrown at an angle of 60 degree with the horizontal. Now then the angle of projection of P1 with the horizontal line will be. The angle of projection of P1 with the horizontal will be, means θ1 we have to find out. Okay, so therefore their height is same. They attain the same height during their motion. It means the maximum height is same. So h, the maximum height for the first projectile P1, that will be u1 square sine square θ1 by 2g, and the maximum height for the second projectile P2, that will be u2 square sine square θ2 by 2g. Okay, so 2g and 2g will get cancelled. So then √3u whole square sine square θ1, that will be equal to u2 square, that is √2u whole square, to sine square θ2, that is sine square 60 degree. Then this will be 3u square sine square θ2 θ1, that is equal to 2u square sine square 60 degree. So sine square 60, that is sine 60 is √3 by 2 whole square. So this will be 3, so u square v square will cancel. So this will be 3 sine square θ1, that is equal to 3 by 4 into 2. Okay, 3 and 3 also will cancel. So sine square θ1, that is equal to 1 by 2. So it means sine θ1, that is equal to 1 by √2. Therefore, θ1 should be equal to 45 degree. So it means the angle of projection of P1 with the horizontal is 45 degrees. So option C is the correct answer. Then here it is told a small toy starts moving from the position of rest under a constant acceleration. There is a small toy which starts moving from the position of rest, which is u equal to 0 under constant acceleration. So acceleration is constant. It travels a distance of 10 meters in t seconds. So it travels a distance of 10 meters in t seconds. Then the distance traveled by the toy in the next t seconds will be. So in next t seconds, how much distance it will travel? Let's say that is x. We have to find that. So we can say the displacement in next t seconds, that will be same as the total displacement in 2t seconds minus the displacement in t seconds. So therefore, it is told that the displacement in t seconds, that is equal to 10 meters, since it starts from rest. So that is ut plus half at square. So u is 0. So therefore half at square, that will be equal to 10 meters, and then acceleration will be equal to 20 by t square. 20 by t square meter per second square. So this is the acceleration, and then so the displacement now in 2t seconds, the displacement in 2t seconds, that will be equal to u into 2t plus half a into 2t whole square. Now u is 0 only, since it starts from the position of rest. This is 0, and this is half a into 4t square, which will be equal to 2a t square. Now the displacement in 2t seconds, so that will be equal to 2 into a is 20 by t square into t square. This will cancel, so this is 40 meter. So therefore the displacement in next t seconds, that is equal to 40 meter minus the 40 meter minus 10 meters. 40 meters minus 10, 40 meter minus 10 meter, that is equal to 30 meters. So 30 meters is the correct answer. Option C is the correct answer. Then here it is told that a person can throw a ball up to a maximum range of 100 meters. How high above the ground he can throw the same ball? Then here it is told a person can throw a ball up to a maximum range of 100 meters or max. How high above the ground he can throw the same ball? So how high he can throw, that has been asked. So it means that if he wants the maximum range, then he should throw at an angle of 45 degree with the horizontal, and let's say the initial velocity is u. So therefore the range, that will be equal to u square sine square theta by 2g. No, sorry, u square sine 2 theta by g. So therefore here the range, that is the maximum range, that is equal to u square sine 2 into 45 degree, that is sine 90 degree, divided by g. So therefore the maximum range is 100 meter, which is equal to u square by g. Okay. U square by g. 100 meters, and how high above the ground he can throw the same ball. Now let's say the maximum height he can reach if he throws vertically, that is h. So therefore I will say that u square v square equals to u square. V square is 0 when you reach at the top, so v square equals to u square minus 2gh. So therefore u square by 2g, that is equal to h. So therefore the maximum height he can reach, that is equal to 100 meter divided by 2. Since why this is u square by 2g, in this I can say this is u square by 2g into 2. So therefore the maximum height into 2. So the maximum height it can reach, that is 100 meter by 2, that is equal to 50 meter. Option B is the correct answer. And here it is told, two balls A and B are placed at the top of 100-meter tall tower. Two balls A and B are placed at the top of a 100-meter tall tower. 180-meter tall tower. Then, so this is ball A and ball B. So ball A is released from the top at t equal to 0 seconds. So here u equal to 0, and so it is released at t equal to 0, and ball B is thrown vertically downwards with an initial velocity u. So let's say this is u1, this is u2, u2 that is u, with an initial velocity u at t equal to 2 second, at t equal to 2 second. So then after a certain time, both balls meet 100-meter above the ground. So at a height of, let's say that is x, at x equal to 100-meter above the ground, the two balls will meet. Find the value of u in meter per second. So this u we have to find out. And it is given that g we have to use, that is 10 meter per second square. G equals to 10 meter per second square. So then we can say, so it means that it is the ball A is covering a distance of 80 meter when they will meet at time t equal to 2 seconds. No, at time, at a certain time, let's say that is at time t equal to t, they will meet. So at what time the first ball A will cover this length 80 meter, that we have to find. So A is equal to ut plus half at square. So therefore S is 80 meter, that is equal to u, that is 0, 0 into t plus half A is g is equal to, we have to do is 10. So half 10 into t square. So therefore t square, that is equal to 160 by 10. So t square is 16, so t equal to 4 second. So it means at t equal to 4 second, they will meet. And then, so the ball B is also, will also cover the distance of 80 meter in a time interval of 2 seconds. Then you have to find the initial velocity. So therefore 80 meter, that is equal to u into t plus half a into t square. And so here t will be equal to 4 second minus 2 seconds. Since why the time interval for which the ball B will travel, that is from t equal to 2 second to t equal to 4 second, where they will meet. So therefore, for B, the time interval is 2 seconds and the acceleration is 10. Acceleration that is 10 meter per second square only. And we have to find out that, and T is 2 seconds. So we have to find out that U. So therefore, we can say 80 equals to U into 2 plus half into 10 into 2 square. So 2 2s are 4. So therefore, 2U that is equal to 80 minus 20 that is equal to 60. So U will be equal to 30 meter per second. Therefore, the initial value of U that is 30 meter per second. So option D is the correct answer. Then here it is told that velocity v and acceleration a in two systems of units 1 and 2 are related as v2 equals to n by m square v1 and a2 equals to a1 by mn respectively. Here m and n are constants. The relations for the distance and time in the two systems respectively are. As you know that v1 that is equal to L1 by T1 and v2 equal to L2 by T2, and acceleration a1 that is equal to L1 by T1 square and a2 equal to L2 by T2 square. Therefore, if we do v2 by a2, v2 by a2, then we will get T2. And similarly, v1 by a1 that will be equal to T1. So therefore, if we divide the second equation, if we divide the first equation by the second equation, then we will get, therefore, v2 by a2, v2 by a2 that is equal to n by m square v1 divided by a1 by mn. A1 by mn is n square. M square this is. So then you can tell this will be n by m square v1 by a1 into mn. So m will cancel. So then we'll get n square by m into v1 by a1. So therefore I can say T2 that is equal to n square by m into T1. T2 T2 equals to n square by m into T1. Then we have to find out the relation of the length. Now, as you know, v1 into T1. So v1 into T1 that is equal to v2 into that is equal to L1, and v2 into T2 that is equal to L2. So therefore, v2 into T2 that will be equal to v2 is n by m square into v1 into T2, that is n square by m into T1. So it means this will be n cube by m cube into V1 T1. V1 T1 is L1. So therefore L2, that is equal to n cube by m cube into L1. L2 equals to n cube by n cube by m cube into L1, and T2 equals to n square by m into T1. So option A is the correct answer. Then here it is told a projectile is launched at an angle of alpha with the horizontal. A projectile is launched at an angle of alpha with the horizontal with a initial velocity u equal to 20 meter per second. Then it is told that after 10 seconds, after 10 seconds, its inclination with horizontal is beta. So after 10 seconds, its inclination, that will be beta with the horizontal. The value of tan beta will be, so G is 10 meter per second square. So tan theta at any time t, that is given as Vy by Vx. And Vy, that is equal to Uy minus Gt divided by Ux. So initial velocity is u, and the angle of projection is alpha. So Uy will be u sine alpha, and Ux will be u cos alpha. This is u sine alpha minus Gt divided by u cos alpha. So therefore, tan theta as a function of t, I can say that is equal to tan alpha minus Gt by u cos alpha. So the value of tan beta we have to find. So here it is told so the value of the angle theta at t equal to 10 second, that is equal to beta, which you have to find. Okay, so therefore tan beta, we can say that is equal to tan alpha minus Gt. So theta is equal to beta at t equal to 10 seconds. So this will be G is 10, 10 into 10 by u is 20 cos alpha, 20 cos alpha. So 25 is 100. So therefore tan beta equals to tan alpha minus 5 sec alpha. So tan beta equals to tan alpha minus 5 sec alpha. So option B is the correct answer. Then here it is told a girl standing on the road. A girl standing on the road holds her umbrella at 45 degree with the vertical to keep the rain away. She keeps the umbrella at an angle of 45 degree with the vertical. If she starts running without umbrella with a speed of 15√2 km per hour, the raindrops hit her head vertically. So it means the rain is actually falling at an angle of 45 degree with the vertical. And then now she is running, if she is running at a speed of 15√2 km per hour with the speed v, then the raindrops hit her vertically. Raindrops hit her vertically, then the speed of the raindrops with respect to the moving girl is. So the speed of the raindrops with respect to the girl, that we have to find out. Speed of the raindrop with respect to the girl. Let's say we call it VRL, that we have to find out. So the speed of the girl VL, that is 15 root 2 kilometer per hour, and the speed of the raindrops with respect to the ground, that is at an angle of, let's say, that is equal to V, but it is at an angle of 45 degree with the vertical. So if you take its components, then we can say this is V cos 45, this is V sin 45. So therefore, the velocity of the girl with respect to the ground, that is equal to 15 root 2 kilometer per hour I cap. Let's say this is x-axis, this is y-axis. So then, therefore, the velocity of the raindrops with respect to the ground, that is equal to V cos 45 minus j cap plus V sin 45 minus I cap. So which is equal to minus V by root 2 I cap minus V by root 2 j cap. Now, velocity of the raindrops with respect to the, so the raindrops is falling vertically when she is running without umbrella. So therefore velocity of the raindrops with respect to the girl, that will be equal to velocity of raindrops with respect to ground minus velocity of the girl with respect to the ground. So this will be minus V by root 2 I cap minus V by root 2 j cap minus 15 root 2 I cap. In, so it is in kilometer per hour. Now this will be equal to minus V by root 2 plus 15 root 2 . Then this is minus V by root 2 j cap kilometer per hour. So it means V by root 2, that should be equal to 15 root 2. Since why? Along, uh, since the raindrop is falling exactly vertically with respect to the girl. Actually, it means that she should, she has to run the opposite. She will run like this VLG, that is 15 root 2 kilometer per hour. So this is minus I cap. This is along minus I cap. This will be minus. So therefore, V will be equal to 15 into 2 kilometer per hour, that is 30 kilometer per hour. The velocity of the raindrops, which is this, and then the velocity of the raindrops with respect to the girl, that is minus V by root 2 j cap. So that is minus 30 by root 2 j cap, that is minus 15 root 2 kilometer per hour j cap, which is also equal to 30 by root 2, I can say 30 by root 2 kilometer per hour. It is the speed of the raindrops with respect to the moving on. So option C is the correct answer.